So, yeah, I'm Lowie Deferme. I work for the Leuven University in Belgium, and we try to implement the hypervisor extension into the official sale model. So, as you all know, RISC-V is an ISA specified in an English document. Apart from this document, there also exists a more formal model in a domain-specific language called SAIL. And this language allows to extract definitions for theorem provers and reference emulators. However, not all ratified extensions are part of the SAIL model, and one such extension is the hypervisor extension. Now I'm going to tell you a bit more about the hypervisor extension. So, hypervisor extension introduces the concept of the virtualization mode. Whenever virtualization mode is off, you just have your normal stack with user mode, supervisor mode, and machine mode. Whenever virtualization mode is on, you can be in one of two new modes. These modes are virtual supervisor mode and virtual user mode. As you can see in the figure, there is no fundamental difference between software running in virtual supervisor mode and host supervisor mode or hypervisor extended supervisor mode. So, therefore, some control and status registers are banked, and they are substituted whenever virtualization is on. So, for example, in the snippet that I show you here, basically it loads an address and jumps to it in user mode. This could be part of both virtualized operating system and a normal operating system, but in the case of a virtualized operating system, these accesses to sStatus and the supervisor exception program counter will be substituted to the virtual equivalence. Okay, the second major feature of the hypervisor extension then is second-level address translation. This is enabled by default whenever virtualization is on. There are several different address translation schemes, and they are different between the two address translation stages. However, they have the same page table entry format, so in theory, page tables can be used between them. And the figure shows like whenever virtualization is off, it's just one normal address translation stage that everyone is probably familiar with. When virtualization is on, addresses are first translated to an intermediate format. Okay, so when we implement the hypervisor extension in SAIL, there are a few things that you have to keep in mind. Of course, our implementation should be functionally correct. Apart from that, it also is good practice to implement something in the model as modular as possible in order to minimize code churn later. And since it's also meant to be a specification or a kind of specification, it should be readable. So you try to not write obscure code in there. I thought I may give you an example on what such an implementation would look like. So for example, when you want to define a new CSR, you first define the layout, which you can see there in the first point. Next, you want this to be accessible with the instructions from the ZCSR extension. So that's what these hooks are for. You basically use the address of the ID of the CSR and you implement it for this ID. And then finally, you have to implement CSR-specific logic. In the case of this CSR, it's to substitute whenever virtualization is on, but of course, it can be way more complex for some of other CSRs. Okay, then second major part, as I said, is address translation. So the implementation that I wrote of second-level address translation is based on unified virtual memory code that was not yet part of the model when I started writing it. The issue was that the original code had code duplication for all the different schemes, and there was an effort going on to refactor this in one unified algorithm. It got recently merged, which is very nice. So my implementation of the two-stage address translation then simply can define parameters for the new stages that the second level introduces. We wrote a top-level error translation function that delegates based on the current fertilization and privilege level. And then you have to make sure that when you do a page walk, you also translate the page table addresses that are used by the guest operating system into physical addresses, because the guest operating system doesn't know about those physical addresses. So the hardest question in this whole inventor, how do you verify the thing that's supposed to be the reference? We took two approaches. So first we wrote unit tests that are based on the English specification, and we executed a real-world hypervisor on an emulator that we extracted from the model. So there are a few unit tests bundled with the model when you go to GitHub. These tests check for regressions. So of course we ran them and checked that we didn't break existing functionality. But then for the hypervisor extension logic, there are no tests available there. So we developed a collection of tests simultaneous with the model. And then we used kind of like a test-driven development approach to implement these features into the model. And then afterwards, we used a few third-party tests to check that the model behaved as the implementers of these third-party tests would have expected. So, of course, all the bundle tests succeed, so we didn't break anything. The test that we developed, there is an issue there that because I developed the tests and the model, that I misinterpret something, and then you won't catch the error. So that's why we all of them checked them against Spike. And then out of the third-party tests, most of them succeeded. The ones that didn't, we manually checked. Two of them failed to non-hypervisor or even non-ISA related aspects. For example, the size of the TLB is one cause of this errors because the sale model has a TLB of only one entry. And then the last one is suspected to be an error in the third-party test suite. And actually, one of the authors of this suite is here this week, and I talked with him about it. And it's an error in the suite. Then, as I told, we also demonstrated the functionality of the model using real-world software. So we choose to demonstrate this using Xvisor. Xvisor is a type 1 hypervisor, and it targets a SBI implementation. And luckily, we all know a very nice SBI implementation called OpenSBI, so we used that. Linux was used as a guest operating system, and then BusyBox was used in user mode to get some basic functionality there and just show that we can do something. I'm very glad that this entire stack boots on the emulator that we extracted from the sale model. It provides extra confidence in the correction of the additions that we made to the sale model. However, I should also note that it's very slow to boot this stack, so it's not a real practical way to test software. It's more a way to test the model. So just a boot and like a simple print, I think is like 13 hours. So in order to test this for yourself, you would need the sale model, the tooling that comes around it, the tooling that you need to build a software stack. So that's why we also made a Docker image available with all the tools pre-built, such that people can check out for themselves if they want to. So this slide is a brief recap of the situation now. So you have the RISC-V Hypervisor extension. It's ratified in the English specification. We have an implementation of it in the sale model that allows you to extract reference emulators. In theory, you could also extract proof definitions. We haven't done that yet. And there is now a collection of hypervisor extension unit tests that follow the same format as the tests that are bundled with the model. Okay, that was my talk. Are there any questions? I'm happy to hear them.
Thanks, Lowie. So we've got time for several questions. questions?
I have a question.
Yeah, of course.
Is this stuff upstream already?
No, it's not yet upstreamed.
It's quite a bulk of code, obviously, right?
Sorry?
It's quite a lot of code, isn't it?
Yeah, there is of course, some of the aspects are highly intertwined. So it's a big difference. And I have to admit, I recently moved on to a different project, so it's not really a priority from my work now.
But you should upstream it, right?
We want to upstream it, but yeah, there is some refactoring work needed because, of course, the sale model keeps on evolving even after I've written this. So you have to make sure that you don't conflict with all these new additions. Yeah.
Okay, thank you. Any other questions? No. Okay, so thanks, Lowie.